Welcome to this Forge College Explainer. I am so incredibly thrilled you're here with us. Now, if you're joining us today, I have a sneaking suspicion you might still be nursing just a little bit of scar tissue from our last lesson on debugging entry points. We went over tracking down those super common, deeply frustrating issues. And hey, we have all been there, right? Staring at a massive stack dump on your screen, completely lost, just wondering where it all went wrong. But you know what? That exact pain, that concrete experience of reading raw logs and error traces, is actually the perfect bridge to what we are doing today. Today, we're taking a full architectural teardown of Solana entry points. We're going to look at the underlying theory and the structure behind the scenes. Because the goal is that when you're building your programs, you aren't just guessing anymore. You are engineering.
So here's our engineering blueprint for this session. We'll start with a fun theater metaphor to ground our understanding, then move right into the core responsibilities of an entry point. From there, we'll tackle parsing strategies, the exact dispatch workflow, and how to use configuration flags. Finally, I'll give you some concrete homework to prep for our next lesson. It's a packed agenda, so let's get right into it. To really wrap our heads around this architecture, I want to set the stage. Literally. Let's set up a mental model. I want you to imagine a super busy theater. But in this theater, the Solana runtime is basically an unruly audience, and they are constantly throwing tickets, which represent your instructions, directly onto the stage. It is chaotic, it's fast, and you absolutely need control. Enter the entry point. Think of the entry point as your stage manager. This is the absolute first Rust function executed by the runtime. It's the strict, no-nonsense gatekeeper whose sole job is to catch those flying tickets, unpack the data, validate the accounts, and effectively route the execution. If a ticket is fake, well, the stage manager rejects it instantly with an error code before the curtain ever even goes up. Okay, so what exactly is this stage manager responsible for? Let's look at the 4 core pillars of their job. Notice how clearly the labor is divided here. On one side, we have our stage manager handling the universal boundary checks. That means parsing, validation, dispatch, and error translation. Now, on the other side, you have the performers. These are your handlers. Your performers don't want to worry about checking tickets at the door. They just want to act. By separating these duties, your performers can focus 100% on the actual business logic and custom computations without being bogged down by basic security checks. The absolute crucial point here is captured perfectly in this quote. Enforcing invariance early yields clearer error traces and makes unit tests simpler. All right, so we know why we need to check the tickets. But how exactly does the stage manager translate those raw byte slices into a language the performers actually understand? You generally have 3 main choices for parsing strategies. First up is tag-based parsing. This one is incredibly fast and extremely compact. It's kind of like color-coding the tickets, where just the first byte tells you exactly what the instruction is. Second, we have enum deserialization, which is usually done via Borscht or SERDI. This is beautifully explicit and super readable in Rust, but the trade-off is that it adds to your overall binary size. Finally, there's length-prefixed parsing. This gives you maximum flexibility, which is great for highly complex or dynamic payloads. Listen, as an engineer, there's no single right answer here. There's only the right answer for your specific program, based on how you want to balance speed, binary size, and flexibility. Let's transition from our theater metaphor into the literal, step-by-step workflow that happens behind the scenes. Think of this as your assembly line. Every single instruction flows through this exact 6-step lifecycle. Step 1, accept the raw input from the runtime. Step 2, parse the discriminant using one of those strategies we just talked about so you figure out what the user actually wants to do. Step 3, validate the accounts. Check the signers, check the owners. Step 4, build the context. This basically means grouping the parsed parameters with the account references into a neat little package. Step 5 is dispatch. You call the specific handler with that context. And finally, step 6, translate any errors that bubble up from the handler back into stable, readable program error codes for the client. That workflow right there, that is the heartbeat of a Solana program. Now, I want you to literally burn this question into your memory. The next time you are staring at a failing transaction log, ask yourself, did the trace enter a handler or was it rejected at the stage manager? If it failed at the stage manager, your trace is going to be really short, and your bug is almost certainly related to parsing, a missing account, or maybe a missing signature. But if it failed in the handler, then you're looking at a deeper logic bug or something like an arithmetic overflow. Just asking this one single question will dramatically narrow down your debugging path and, honestly, save you hours of pulling your hair out. Moving on, let's talk about the control panel. If the stage manager runs the show, how do we give them instructions? We use configuration flags. Think of these as the actual knobs and dials on your stage manager's control board. Let's look at a few common ones. There's strict_parsing. If you set this to true, the stage manager instantly rejects any unknown instructions, no questions asked. Then there's early validation, which runs extra and variant boundary checks right at the door. Logging level is exactly what it sounds like. It controls your verbosity so you can see more or less of what's happening. And compatibility mode might be used to accept older ticket formats if you're upgrading a program. Flipping these switches literally shifts the burden of responsibility between your boundary checks and your core logic. And the settings you choose depend entirely on what phase of engineering you're currently in. The contrast here is actually pretty striking. In development, you want loose, noisy settings. You want strict parsing off so you can iterate and test quickly, and you absolutely want your logging level set to debug so you can see every tiny detail of what the runtime is doing. But in production, you completely flip the script. You want fast-failing, highly strict settings. You turn strict parsing and early validation to true. This drastically reduces your attack surface and keeps the program incredibly secure. You are effectively trading developer convenience for deterministic, hardened safety.
All right, we have covered a ton of ground today. Let's wrap up all this theory and get you prepped for the next phase.
I have a concrete assignment for you, yes, real homework, to bring to our next lesson where we actually configure templates. First, I want you to evaluate your current project and pick a preferred parsing strategy. Decide right now if you need the raw speed of tags or the explicitness of enums. Second, define exactly 3 invariants, 3 non-negotiable rules that you want your stage manager to enforce at the boundary before anything else happens. And third, decide what your default configuration flag should be for your current dev environment. Having these architectural decisions made ahead of time is going to make the actual code configuration an absolute breeze. Let's leave it on this final thought. Strong boundaries make predictable programs. I really hope this architectural teardown has empowered you to look at your Solana programs not as a mystery, but as a deliberate set of engineering choices. Thank you so much for joining me in this explainer. As always, this content was brought to you by Forge College. For more deep dives into the subject, and to explore our massive library of other Web3-related topics and engineering resources, please visit our website at forge.college. So grab your homework checklist and get to work. But as you do, ask yourself this. What happens when your stage manager's configuration accidentally lets a malicious actor slip onto the stage? Think about that, and we'll answer it and configure these templates for real in the next lesson.